Welcome. In this video, we will take a look at a third example using the chain rule. We have a function here we'll call h of x is the square root of 2x cubed plus 3e raised to the x squared. So initially, we can think about rewriting that square root, that's the outer function or the outer operation on this function. We can rewrite that as a 1/2 power to make it a little bit clearer. So we have 2 raised to the third power plus 3e raised to the x squared, all raised to the 1/2. So here we can see that we have some inner function, everything there in the parenthesis, and an outer function here we could call the 1/2 power. That's the last operation on our function h. So we can consider again the outer and the inner derivative separately. So let's take a look at that outer derivative using the 1/2 power and the power rule. So overall derivative here is going to be called h prime of x. And we'll start with that outer derivative. So f prime of x evaluated at g. We'll do this in blue. Well, I want to take that outer power, bring it as a multiple, and raise the rest of the stuff to the n-1. So all the rest of the stuff, that inner function, I'm going to raise now to the 1/2 minus 1, which would be -1/2. So that is my outer derivative evaluated at g. Now we can consider our inner derivative, which is g prime. So we have the g prime, and we'll do this in red. So the inner function here, we have really two terms to take. The 2x cubed is just another power rule. So this inner function will start with a derivative of 6x squared. So that's the derivative of our first term. The second term, though, this actually has another chain rule involved with it. So we need to take a little bit more time to dissect what this derivative is. We'll notice that we have 3 times e raised to the x squared power. Now, exponentials by themselves aren't too difficult. They're just their own derivative. E to the x is always e to the x in its derivative. But here we have e to the x squared. So we can kind of think about this as a new chain rule to take this portion of the inner derivative, where we have x squared as that outer function in the exponent. So when I consider taking an exponential derivative, I just want to rewrite that derivative and take the derivative of the inner function. In this case, the inner function is the exponent, which is x squared. So let's write that out. We're going to have plus, the derivative here of this next term is in 2 pieces. The first is the outer x, 3e raised to the x squared. So we're rewriting our exponential. And then we're going to take the derivative of the exponent, or the outer function. So this is derivative of x squared, which is going to be just 2x. So there's my inner and outer derivative portion for that kind of tiny chain rule problem that we had to work out in the inner derivative of the overall h function. So we'll finish that parenthesis off, and this will be the final derivative for h prime of x. So we started with a outer derivative, multiplied it to an inner derivative that had a kind of a chain rule inside of that inner derivative. So hope this is helpful with problems with multiple chain rules. I look forward to seeing you in the next video.